But yeah, while you guys are doing that, I will go ahead and give you guys a quick intro to Docling. Before we start off, I'm just curious, has anyone already heard of Docling before at all? One person. Okay, cool. I actually really like that because that means you guys won't have super difficult questions, hopefully. But if you guys have not heard of Docling already, it is a Python project. It's an open source Python project. It's a library that's intended to help you convert documents of various formats into more AI-ready formats. So if you guys work in AI or use AI, I imagine everyone at PyData has interacted with some sort of AI application in the past. And you know that most documents, or at least most AI pipelines, require documents to be in specific formats before they can be processed, right? So usually organizational documents are going to be in these more complex formats like PDF, PowerPoint formats, doc formats. There might be images, scanned documents, Excel documents. All these various formats in real-world organizations can't just be fed directly into an AI pipeline. You can't just use that data directly for training. You can't use that data for inference, right, et cetera, right? Those formats need to be converted into some sort of format, some sort of text or standardized format that's going to be more AI ready. That's essentially the core of what Docling does, right? It's converting those formats, all those various complex formats, into AI-ready formats while preserving a lot of the structure of those documents. And we'll talk about why that's important and how Docling does that in a second. But essentially, it takes all these various formats and converts it into Markdown, HTML, or JSON format, or allows you to export into Markdown, HTML, or JSON format. And from there, of course, those formats are what's more traditionally considered AI-ready formats, right? So let's look at why we need Docling, right? So if you look into the open source space now, or just look at the services that are available for doing document conversion, right? Or especially with PDFs, a lot of them strip text without any structural understanding, right? And generally speaking, that can be fine, but to get the most value out of your data and to use your data more effectively, you need some structural understanding. So this is a classic example that we like to use as to why it's important to have structural understanding. So a couple of years ago, there was this phrase, vegetative electron microscopy, that just started appearing in papers. These were all peer-reviewed scientific papers, and this phrase started appearing and no one really knew where it came from, right? It was kind of a nonsensical phrase, and people were like, why is this starting to be used in papers? I've never heard of this phrase before. It turns out, in a scientific paper from 1959, this article, the phrase, the term vegetative and electron microscopy actually spans 2 columns, right? So using a more simple PDF parser, you end up with this strange mistake where this nonsensical phrase appears because the structure of the document is not well understood, right? The structure of the document is not well extracted by a simple parser. If you look at what Docling can do, and this is just a very basic feature that Docling has, is recognizing that structure and being able to accurately separate vegetative from electron microscopy, right? Scientific document, very common structure. A lot of documents have this 2-column structure. Docling, at its core, is able to understand that structure and separate and parse the text correctly, preserving more of the semantic meaning of your documents. Again, if we look at some low-level PDF parsers, there's a lot of content that you miss out on when you just strip text, right? The main thing that we like to look at beyond the text itself, we can see headers, right? Headers are going to be lost. There might be captions that are lost. Tables are completely lost. Docling processes tables and handles them, allows you to export them in various formats effectively. Tables are going to be lost. Images are just completely lost and may be saved for some of the text that's embedded into the images. But regardless, you're losing a lot of structure. The actual extraction is going to be incomplete and you're losing valuable data from the data that you have. If you look at what Docling can do, and this is just an HTML export that Docling, after converting the document using Docling, you can see the tables are preserved. One thing that we really like to highlight about the table preservation when it comes to HTML exports is the preservation of merged columns. If you've worked with Markdown before, you know that that's kind of a pain to deal with, but HTML merged columns, all the tables are preserved, images are going to be preserved, figures, text, captions, etc., right? So general high-quality structured extraction from your documents. So once again, before we actually get into the workshop, I'm going to put this QR code and also this link up there again. If you wanted to follow along to the workshop, you can go to that link. Let me just pull it up right here just so you can see what you should be looking at. You should be looking at this right here. Yeah, so there's a pre-work page with a couple of little things that you may have to do depending on what environment you want to run it in, but otherwise we can basically get started with workshop. So in the workshop, we'll go through there's 3 pieces of the workshop. The first one's going to be conversion, the second one's going to be focused on chunking, and the third one's going to be a multimodal RAG pipeline. The first one, as I mentioned, is conversion. So Docling actually has 3 different conversion pipelines, unique ones. So the first simple pipeline is of course, a simple pipeline, right? There's a lot of documents that don't necessarily need advanced parsing. There's no reason for you to run, OCR on a Word document. So there's a simple pipeline for easily parsable documents. And from that pipeline, you assemble your Docling document, and then from there, you're able to export it into various formats. We'll talk about the Docling document a little more in a second. The second pipeline is going to be the PDF pipeline. So within the PDF pipeline, you can actually process both scanned and also standard PDFs and more parsable PDFs. If you have scanned PDFs, there are other models within that pipeline that you can enable, right? There's OCR models, layout structure models, layout analysis models, and table structure models. Again, it assembles into a Docling document, which you can then export into various formats. The final pipeline is a VLM pipeline, so a visual language model pipeline. The Docling team has actually trained a visual language model. It's a 256 million parameter model, so very small if you have a concept of the sizes of LLMs, but it's a very small visual language model, and the purpose of that model is to take images, so any scanned document, and convert that into Docling document format. It's actually trained using data that has been extracted from PDFs using the PDF pipeline, so you end up with very similar results. It's just more document type agnostic because you can scan anything in, right? So, let's see. Let's go ahead and get started on lab 1. So one of the benefits of the labs and also the benefit of Docling is because of how lightweight the pipelines are. You can actually just run them in Colab, which we like to have people do so that they don't have to do too much local work. And if you have any questions, you run into any bugs going through it, please just raise your hand and let me know. But again, the first lab is just focused on conversion, and after some basic imports and installations, you can go through these yourself, but the most important piece, so we're going to set an output directory here, the most important piece to remember from this lab and how to use Docling as a whole is just these 3 lines, right? It's very simple. You create your document converter instance, you convert your document, and then now you have this doc, which is going to be a Docling document, right? So if we take a look at the document quickly, just to make sure, we can see standard scientific document, right? Standard PDF for the scientific document. This actually happens to be the Docling scientific paper if you want to go check it out yourself. But regardless, right, we have somewhat complex structure. We have some images within the document. We have these figures, captions, etc. Let's see, we might have some tables in the document, some other figures, right? So pretty standard, complex PDF document. We do the convert, and now that we have our Docling document, we can actually just export it into various formats. So here we have just printing out the first 2,000 characters in Markdown of that document after the conversion. We'll take a look at that deeper in a second, but first let's take a look at what Docling is actually extracted, right? So we can see Docling has the document title, the number of pages, the number of tables, 1 table, and 6 pictures. So we've got a document that extracted 8 pages, 1 table, and 6 pictures. We can take a brief look at the document structure. Later we'll dig into this a little bit deeper, but you can see, right, even just from these first few lines, you can tell it's preserving a lot of structural elements of the document, right? It recognizes section header, item, text, text, section header, text, text, etc., etc. So when we actually export into those Markdown or JSON formats. So the Docling document format is actually natively a JSON format, right? And the reason why we use JSON is because JSON has a lot of metadata fields that allows you to preserve document structure. If we go and examine what those Markdown and JSON exports look like, we can pull it up here. If you take a look at the Markdown, right, you can see these titles are getting preserved. I don't know, can you guys see that fine? I'm not sure in the back, especially if it's difficult. You can't see it. Okay, let's zoom in a little bit. Great. Markdown, right, so we have these titles preserved in Markdown, headers, headers, text, let's see. We have links preserved. One more interesting thing is list items are preserved within the document, text, images. We have placeholders for the images. We'll talk about how we can work with the images later, but essentially the idea is, right, well-preserved Markdown, structurally sound in terms of the source document. Let's see if we can find a table. Here's a table, it's a Markdown table. This doesn't look great because it's zoomed in, but there you go. markdown table, right? So again, preserving structure, preserving table structure, preserving text structure, and extracting text accurately. If we actually take a look at the JSON as well, just to kind of explore what the JSON or the Docling document looks like, it's a bit hard to read if you can't read JSON, which I don't think most people can read JSON, but you can see, right, there's a lot of this structural metadata that goes with each of the text chunks, right? So every single text chunk comes with some location metadata. We'll show you how to use that later, but essentially like the actual coordinates of where that text chunk is on the page. It mentions the type of text, right? This is section header, and then some other basic metadata about the text. If you scroll through, you'll see there's section header text, there's going to be list item text, body text, all of that. Great. So that's just simple conversion using Docling. I hope everyone was able to follow along there. There's a couple of other things you can do with Docling, right? So with those tables, as I mentioned before, you're able to export the tables into various formats. Here we go ahead and work with a document that's a little more table heavy. A little more table heavy document, right? We've got a couple of other more complex looking tables within this document. Let's see, here's some bigger ones. Great. So more table heavy document. Again though, it's the exact same thing. Document, converter, and then converter.convert, right? You just have to convert the document. From there you can export that table into various different formats. So because Docling is tagging each text piece and each text chunk that it's extracting, you can actually work with specific elements of each document, right? So in this case, we're just selecting for all the table items, and then we can export the table items. Here we export them into HTML to display. There's supposedly 8 table items, and again, we can scroll through and check out what that export looks like. Great, so we know how to work with text, we know how to work with tables. Lastly, we're gonna look at images. So within our converter, there's actually pipeline options that you set. So I mentioned before, right, within that PDF pipeline, there's all these options, OCR table, analysis, layout analysis, whatever, right? You can actually set those pipelines just through Docling. So here we're gonna set generate page images and generate picture images equal to true. So essentially what that means is going to save every page its own image and then save all the images within the document as well separately. This is just so that we can display them later. Once again, we're taking our Docling paper and then we're running that converter.convert after setting our PDF pipeline or format options within that document converter instance, right? So then we run that converter again, and once we convert it, we're creating an output subdirectory for the images. We save the page images, we have 8 page images, and then we can export the figures and tables as images. Once again, table items and picture items are all going to be tagged within the conversion after it's been converted to that Docling document format. So again, you can treat those separately or handle them separately. So now you have your page items and image items saved separately as PNG images. And then we can go ahead, this is just a function to actually display those images, and we can take a look at what images Docling has extracted, right? So here, let's take a look. There's a bunch of images. So this part specifically may take a second. Actually, no, not this part. This part will be pretty fast. But, right, picture images here, we can see the captions. So another key point of structural understanding that Docling has is because the extraction comes with structure, the captions for each image are actually stored with the image, right? So every image caption under the image is going to stay with the image. It prevents you from having random captions showing up in your text that are just unrelated because the image is not displayed. It does some basic text extraction out of the image as well. So here we have the caption that goes with the image. Let's take a look to make sure that that was accurate. That's not the right document. It's this one. So first image here, figure 1, sketch of document pipelines, blah, blah, blah. Let's see, figure 1, sketch of, great. So image, text goes with the image with the caption. That does it for every single image. You can go through this if you'd like, but essentially, right, we've taken all of the images, all of these figures, and stored it with captions. Another thing that we can do with Docling, because we have the locational metadata, right, because we store all of that, all those coordinates with the documents, we can actually also visualize what Docling sees, if that makes any sense. So essentially, if we actually use this layout visualizer as a function within Docling, you can draw bounding boxes. Essentially what it's doing is drawing bounding boxes using those coordinates that we extracted during the conversion. So we draw all these bounding boxes around the elements within this document. And as you can see, we have section headers, text, section header, text, etc., right? We have footnotes also recognized, also something that people really like. List items, again, recognized. You can see even the sideway text, we have a page header here. Picture with the caption recognized. And this is all just using information out of that Docling document that we converted, right? So all that metadata, all of that location and coordinate metadata is used to do this tagging, essentially. So one other thing that Docling can do as well is, because, again, you're storing these images separately and you have them tagged as such, you can do some enrichment features. So a couple features that we won't be demoing today, there is formula enrichment and there's code enrichment. So you can actually extract formulas into a text, you can extract code into, or recognize code into code text. Here, this is just some, if you have Colab. Sometimes this won't run super well in Colab because it needs to actually download some of the models, and your Colab may not have enough space depending on what tier Colab you have and how much Colab is willing to give you for free at any given time. But here, there's a couple of visual language models that are integrated into Docling already. The main one that we use is Granite Vision 3.2. 2B, it's 2 billion parameter visual language model. And so what we're doing here is essentially we're creating that PDF pipeline, but now we're setting the picture description option. So essentially we're taking every single image within the document, and we're generating picture descriptions, so essentially text descriptions, detailed text descriptions of every image. You can set the prompt whatever you like here. Perhaps you may have a document that has a lot of medical images, and you can set a prompt that's tailored specifically to the images within your document, or you have a lot of charts. Whatever you want to do, you can set the prompt here. Again, generate page image equals true, and we're going to scale the images up a little bit to make sure we have detailed images for our conversion. And once we actually do the conversion, right, so we're using this enriched document converter. Again, it's just a document converter with the picture description VLM option set. We can see here, again, we're displaying all the images that have been extracted, but now, not only is there the caption, right, the figure, wait, you guys can't see that. No one raised their hand and told me. Not only is there the figure caption that goes with it, but there's also going to be annotations, right? So these annotations are going to be those AI generated or VLM generated descriptions of the image. Same concept, right? It's just a detailed description of the image. It allows you to, if you were building, for example, multimodal RAG pipeline, like we're doing in Lab 3, you can use this text description to essentially embed the image or pseudo embed the image. So same idea, right? Charts, figures, etc., etc., etc. Okay, the final piece is that visual language model piece. So this one is a bit more difficult, or far more difficult to run in Colab because it's a 2 billion parameter model. It should, depending on your device, well, no, it easily runs on your device just fine. It sometimes will run in Colab just fine, again, depending on the temperament of Colab. Essentially here, I misspoke. This part is allowing you to do it through Olama, right? So if you download that Granite Vision model through Olama, you can essentially connect Docling to your Olama instance and have that running on your local device to do the image descriptions. Okay, now we get to the VLM. So the VLM, this is the Granite Docling models I was talking about before. This is using small Docling actually. There's 2 versions of the model. The original one was small Docling. Granite Docling is a newer version. This one is using the old version, but feel free to go and check out the new version as well. But essentially, right, we're setting this VLM pipeline. We're setting the model that we're using as small Docling here. And then we're doing the document converter. There's a couple accelerators you can use depending on your device. All of that is in the documentation at docling.ai. But again, we're just converting the document, and when you actually export it and then take a look at the converted document, it's going to end up being very similar. The hope is that it's very similar. If we look at the VLM document, it's essentially the same, right? It's the same conversion. It's just that this time we use a 258 million parameter model to do conversion as a scan document. So any scan document will do conversion into Docling document format. Again, from this Docling document format, you have all the options to export into other formats. And that is it for conversion. Are there any questions about document conversion? Nothing. All right, great. Then we can move on to the next section. Actually, before we move on, I do want to show you. So if you go, so the Granite Docling model is actually also an open source model. It's available on Hugging Face. It was actually the #1 trending model on Hugging Face for a while. The CEO of Hugging Face actually tweeted about it. So pretty cool model. If you give it a like, maybe it'll stay up there for a little longer. But regardless, model's available open source on Hugging Face, and there's also a demo space available. So you should be able to Click on this demo, and then you can upload your own scanned documents just to test it out. There's also a lot of different little pre-existing documents that are available here to test out. You can feed a little prompt, and then it may take a second because it's Hugging-based. But once it's converted and you look at the markdown, you'll see that these, the important part for this demo specifically is that the functions are rendered correctly in tech. But we can take a look at that in a second after it's done converting. So, lab 2. Actually, not lab 2. So, the reason why we have this VLM pipeline, the reason why there's kind of a push to go towards VLM is that a lot of people have been using VLMs as a means of document conversion because scanned documents are essentially images. So one thing that we like to do is compare ourselves to the various other VLMs that are commonly used for this sort of document conversion or text extraction. The thing is, none of these VLMs are specialized to do just this, right? They're not specialized to do document conversion specifically, so when you feed a prompt for it to do conversion, you get decent results, but you're still losing text, right? You're losing some amount of text here, you might lose table structure here or there, and most importantly, your inference time is going to be a lot higher because these models are just very large and not purpose-built, right? If you look at Grant Docling, 4 seconds, same conversion. Awesome. Okay, so I feel like everyone here has probably already heard of RAG before, right? Retrieval Augmented Generation. Essentially, you're retrieving information out of the database of your data, and then you're feeding that information to a model to help it generate a response. The core part that Docling assists in here is actually getting your information into the database, right? So before you can actually get your information into a database, before you're able to vectorize it, you have to chunk your text, right? Your text needs to be fit within certain context windows for your embeddings models, and you want those chunks to be semantically coherent, right? So if you had a embeddings model and it was a 512 token limit embeddings model, for example, the naive thing to do is theoretically you could just chunk your entire document into 512, 512, 512, right? Over and over and over again. You could have 512, exactly 512 sections of text for all of your chunks. The reason why this doesn't work is what ends up happening is you have chunks that are split down semantic meaning pieces, right? So if that makes sense, chunk 1 ends in the company's revenue increased by 25% in Q3, chunk 2 starts with 24.4 compared to Q3 2023, right? So if you were to search something like 2024 revenue growth, you might not actually retrieve that first chunk at all, which actually has information because the first chunk doesn't mention 2024. You've lost some of the semantic meaning of the first chunk by splitting it down the middle. And again, your model is going to lack the answer, complete information to answer correctly. If you have more semantic aware structure aware chunking, right, you can chunk based on sentence structure, you can chunk based on paragraph structure, but again, having these 2 chunks that are going to be more semantically coherent are going to increase the value of your retrieval. You have more complete self-contained thoughts within those chunks, there's clear topical boundaries, again, significant context for retrieval, and those natural section breaks in the structure are going to be preserved. So, how does Docling actually enable chunking, right? So as I mentioned before, Docling has all of that structural information as part of its extraction when it turns into that Docling document format. So let me make sure, great. If we go to the chunking piece, we can take a look. Okay. So this whole lab is just dedicated towards showing off a couple of the core chunking features that Docling has. This runs very, very quickly because it's just doing chunking basically. But first, same installs essentially, and then some other installs for visualization. And then here we're doing the exact same thing as we did in the last lab. We're just doing conversion, right? We're setting PDF pipeline options here. We're going to turn off OCR just to make it run a little bit faster. And we're going to do generate page images equals true so that we can actually extract the images. Here, the example doc that we're going to use is going to be perhaps a little more complex of a document, right? You have a very image-heavy document, very structurally complex document here. Again, just to kind of flex the capabilities of Docling. So, here we're going to build a chunk analyzer, so this is going to help us not visualize, but put into numbers how quality our chunks are, right? And help us visualize the sizing of the chunks to make sure everything is looking correct. So Docling actually has 2 pieces of its base chunker interface, just a chunk and a serialize. Very simple, right? You just have the chunk here, serialize here. It just essentially it iterates through the Docling document and chunks based on structure in the Docling document. So there's actually two specific ways that Docling does chunking. The first one is going to be that hierarchical chunker, which is going to chunk strictly based on document structure. So here, you create your hierarchical chunker, and then you can generate your chunks. So we're setting our embeddings model to the Granite embedding 30 million parameter embeddings model. And when we actually chunk the document with the embeddings tokenizer, you can see we end up with not the best chunks, right? So if we actually look at the chunk analysis in the table, we can see there's a lot of really small chunks, and there's also one really big chunk. It's going to be greater than 512 tokens, which is the context window limit of our embeddings model. So hierarchical chunker clearly doesn't do super well. If we actually look at the sample chunks that the hierarchical chunker creates, what we'll end up finding is that in this document, especially when you look at these little pieces, all of these little tiny paragraph breaks end up being their own chunk, right? So the hierarchical chunker strictly is focused on structure, so you end up with all these small chunks that are structurally coherent, but sometimes too small, sometimes too big, because it's just chunking on hierarchy. So the actual recommended way of chunking the Docling has is the hybrid chunker. So the hybrid chunker is going to balance both size and respect hierarchy. If we take a look at the hybrid chunker, the same idea, right? You create your hybrid chunker instance. Here you can set your embeddings tokenizer. So when you set the embeddings tokenizer, it actually gives a hybrid chunker a queue as to what size tokens, what is the max token limit for your chunks. And again, here we're doing our chunking, and when we actually examine the chunks, now there's 73 chunks. Still a lot of small chunks, but now there's only like 36 small chunks as opposed to over 100. You can see slightly better distribution of chunks, and our max chunk size is 506 tokens instead of 600 plus, right? So again, chunking within the limits of your embeddings model while still respecting structure. The average chunk size is going to be much higher, and again, just more size-aware chunking than hierarchical chunking. So that's awesome, right? Docling is enabling structure-aware chunking while also being able to balance the size of the chunks. What else can Docling do specifically for chunking? One thing that Docling does great is also being able to limit the chunk size, right? So this is maybe not the most useful depending on your use case, but sometimes you may want to chunk smaller because you may want more fine-grained retrieval. Maybe your entire document is just a list of things and you just want smaller chunks for whatever reason. You can set that here, right? You can set your max tokens for your chunker here. The other thing that Docling does wonderfully, which tends to be a little more useful, is contextualization. So as I mentioned before during the conversion, because Docling is preserving the document structure as well as the headers and the captions and the list items and tagging all these pieces, you can actually use this feature called contextualization, which is going to increase the value of your chunk. So if you look at these original chunks, so we're just doing another conversion here, except this time we're using the contextualize to contextualize the chunks. When we look at the contextualized chunks, we can see, so this original text was bridging the gap between poverty and prosperity, and then this is analog world 2022, so that one, okay, so that's a fine chunk. Let's look at the first. No one could have predicted the events of 2022. Okay, great. So this is a better example. If you look at these first chunk 1, chunk 2, in chunk 2, you can see the original chunk is just going to be the text from that chunk. But what contextualization does is, because it recognizes the header is relevant to the rest of the text beneath it. If we look at this text here, right? If you were RAD, for example, you wanted to retrieve a message from co-founder, president, and CEO David Kaiser. If you were to just search that and do a semantic search, you may only retrieve that first paragraph chunk because only that first paragraph chunk is close to the header, right? What Docling allows you to do with contextualization is it takes the header and it adds it to every single chunk to the chunks that are under the header. If that makes sense. So if you look at the chunks, right, each chunk, the original text may have just been that paragraph of text, but now each chunk includes a message from our co-founder, president, and CEO, David Kaiser. So every single chunk has the context of the header from the section that it was in. So just slightly more complex and enabled contextualized chunking. And I think that is it for chunking. Are there any questions about chunking? Nothing. All right. I hope that means I'm doing a really good job. Okay. So our last piece is going to be well, actually, is anyone following along, or is it just kind of just listening, which is totally fine. I don't mind either way. But if you wanted to follow along, that lab will stay up forever, and you can go and try it on your local device. I just want to make sure if there was any bugs in the code, because there was a presentation I gave a while ago where there was a bug at the very beginning, and no one asked me any questions for the entire session, and I found at the very end no one was able to follow along because there was an import issue, and it was like one line and it fixed it. But okay, I hope that's not the case. So our last one is going to be multimodal RAG. So as I mentioned before, because Docling is doing this extraction on images as well, and you can actually use Docling to do the image conversions, we can actually run the multimodal. We can create this multimodal RAG pipeline to allow you to do RAG on a document that includes images, figures, charts, etc. Right? So multimodal RAG is just RAG with different modes. If we look at our third lab, it's this one here. Okay, yeah, so the third lab is going to be building out that entire multimodal RAG pipeline. Let's see. Okay, so first step is still the import, setting up and installing, etc. It's the same as before. Here we're actually going to use Milvis as our DB just because it is open source as well. Some logging, some installs, a couple of required libraries. I'm actually realizing now that I'm going pretty fast and I'm not even going to come close to using 90 minutes. So if you would follow along and you do have questions, feel free to definitely ask those questions if you're running into any issues.
Here, I'll
oh, okay, awesome, thank you.
I lost you at the tiny URL to bring us to the in the first place.
Okay. That's good to know. All right, it's this one. Wait, no, not this one. It's this one. Does that not work? And now I have to start all the way over from the beginning again.
I was able to find it by searching Branded Community Docling Workshop.
Yes, yeah.
Okay, thank you.
Of course. Anything else? Okay. All right. Okay, so this last one is going to be a RAG pipeline, multimodal RAG pipeline. So we have a significant number of imports here. We're using LangChain to actually build our RAG pipeline. Here's where you actually are going to want to have your replicate account set up. I don't know if people wanted to do that, but Replicate is a model inferencing platform. There should be a link within the instructions to give you like 50 cents of free credit. IBM actually maintains a lot of its open source models on Replicate to allow for free or relatively cheap inferencing. I got 50 cents credit on Replicate like almost a year ago now, and I still haven't used all 50 cents of it, so it's pretty cheap, and the models that IBM hosts on there are all like, they're smaller open source models. But anyways, okay, so here we're going to actually set up to build the RAG pipeline. We're going to use our Granite 30 million parameter embeddings model, which is a small open source embeddings model. Once we load our embeddings model in, here's where we're going to use Replicate. So actually within the lab, it gives you an option to also run in Element Studio if you choose to. Again, this is just more a more local running of the lab, right? Essentially, you can download and install models in Element Studio and use the models within Element Studio, which would be on your local device. So here we set our Replicate API token. We're using that Granite Vision 3.3 2B vision model, and we're going to keep a low temperature for reproducibility. And then we're going to load the Granite model. This is an 8 billion parameter open source model, also through Replicate here. If you're using Google Colab, that's just the easiest way to do it. So in the conversion step, we're going to do some of the same things as we did in the last two labs for conversion. Here we're going to set our PDF pipeline options. So we're going to do OCR to false. Again, generate picture images and generate page images equals true. So this is going to help us with our visual grounding later, and I'll kind of explain well, I will explain what that is when we actually see the visual grounding results. So we've converted our document converter with visual grounding. Here we're going to create a temporary doc store, so it's just going to store all of these little pieces that we're converting after the conversion. And then we're doing the actual conversion here. So we're using that image-heavy document, that complex image-heavy document here. Fun tidbit, we've actually been using this specific document for our lab examples for also more than a year now, not just for this lab, but also for other Granite-based RAG labs. We've always wondered exactly what the Midwest Food Bank thinks when they look at their like AWS hosting instance or whatever it is they have and see like hundreds of people hitting it randomly. But this is the document that we've been using for a very long time now. Again, image heavy, very complex document. And then when we do the actual conversion, we're just converting using the pipeline that we set before. We're converting here, and then we can see, so 20 pages, 2 tables, and 53 images. So again, complex document. There's a few things that we need to do in order to get the metadata stored with the image. So we're actually processing the different chunks slightly differently because the text chunks versus the image chunks have metadata stored in a slightly different way. But essentially here we're taking all of our text chunks and then we're creating these documents, which are going to end up being our chunks, these documents with this chunk metadata, right? So essentially this is taking that locational metadata out of each of the chunks after conversion and storing it as part of the document metadata. So once we do that, we actually end up with 72 text chunks with visual grounding metadata. Okay, so 72 text chunks all completed. We then have table chunks, so same idea here, right? We're taking that visual grounding metadata out of the provenance data that is already stored after conversion. And we're storing it with the provenance data in the metadata document again. So one table document created here. Lastly, so the vision one is the one that's a little bit more difficult. So in this specific example, we're using the replicate. We're using replicate to actually process those images, right? So we're using an outside model to do the processing. Because it's handled externally, it's a little more complex to keep the metadata tied with each image, but essentially this is a very long function that does just that, right? You're essentially going to take that provenance data that's stored with the images themselves, and then after you run the conversion, so after you run a conversion with the generation prompts, so it's just taking our generation prompt and every image, feeding it to replicate so that it can generate a text description of the image, and then once it gives us back the text description, we're adding in that locational metadata with it, as we did before. So now we have the provenance data stored here, and now after we process it, we can see, okay, great, so 53 image descriptions created, so we can process all the images, all the text in the single table. We'll go ahead and display some of the process documents just so we can kind of see what Docling has done with them. This is just displaying 3 texts, 3 images, and 3 tables. There's not 3 tables, but you get the idea. Here we can see, let's see, text chunked examples, so text, 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 table example here, and then more interesting is going to be these image examples, right? So we have the image along with the AI-generated description here. Okay, great, so we can clearly see, right, there's some AI-generated description that's been stored with all of the images in our document. Very detailed descriptions. Okay, great. So visual grounding. So visual grounding is the ability to ground your sources in, okay, I was going to say ground your sources in a visual sense. That doesn't make any sense at all. It's essentially, it's allowing us to see the result on the page that it's being extracted from. So when we build visual grounding, we want to be able to see where the information is being extracted from on each page. So if you're running RAG and you retrieve a couple of relevant pieces of text and your model is generating some response, you want to be able to see where the evidence that the model is pulling that response is from, especially when you're doing multimodal RAG, because you want to make sure that the images are being processed correctly, right? That the images are being understood by the visual model correctly. So having the images actually verifiable by a human at the end of the pipeline makes it a little bit easier, because that way you don't need someone going through all of your entire documents to verify every single image. It's just at the final retrieval, you can essentially double check the response was correct, right? So here we're going to create our visual grounding function, and it's essentially just going to take that provenance data that we stored before and then draw a bounding box for us around where in the document that provenance data is. And that's why we stored the page images and picture images separately, so that we could actually draw the bounding box on the images of the pages. So this is a function to do just that. So it's extracting the metadata, so that location metadata from the images. So this is for image and one of them is for text. But both of them do the same thing as extracting that metadata and drawing the bounding box. And then it'll display the actual page image with the image highlighted. So after that, we can go ahead and just populate our vector database using all the chunks that we already created. So we're using Milvus here, and then we can add all of our documents, so all these text chunks and all of our image chunks to the vector database. We can see there are 72 text chunks, 1 table, and 53 images added. Perfect. And then we'll test the retrieval really quickly just to make sure that everything was added correctly. So we'll ask a test query here, how much was spent on food distribution relative to the amount of food distributed? Okay, so that should be something that's answered within this document. And then when we actually display the retrieved result, we can see that it's retrieved several chunks. We don't display the images with the retrieval, but we can kind of just see the text description of the retrieval. Let's see, text chunk. Okay, well, it doesn't quite actually matter what it retrieved. We just need to make sure that it was actually retrieving chunks from the database to ensure that our database is filled with.
I was just wondering, so when you're getting which part of the image that the model was using to respond, what part of the model is answering that? Is that coming from the attention heads or?
Sorry, it was for the location of the image?
Right, how are you figuring out what location in the image was actually relevant?
So the location, in this example, we're not necessarily figuring out what location in the image is relevant. We just need to know where the image on the page is. So that just comes at the extraction part. So
okay.
Yeah, sorry, that may have not been clear. So the idea is we don't necessarily need to know exactly what part of the image for each image it was relevant for. We just need to know that that was the image the information was extracted from, so that when you go and do the retrieval, you can look at the original image and say, okay, that's a reasonable processing of this image, or that was an incorrect processing of this image.
Okay, so the visual grounding is finding the image on the
The visual grounding is just locating the image, exactly. After you do the extraction from the vector DB, locating where that chunk of text is coming from on the original page.
Okay, cool.
Yeah, good question. So yeah, it's just verifying that the original document was converted correctly. And again, it's more just important because even Docling is imperfect, right? Any sort of text extraction they use is imperfect. So verifying that the original document was extracted correctly after you do the retrieval is a benefit that Docling provides. So we can finally actually assemble our entire RAG pipeline here. So we're assembling our laying chain RAG pipeline, which is going to name it RAG visual grounding. So first, it's to retrieve the chunks, right? It's just doing the vector DB as a retriever. We're visualizing where each chunk is coming from, so it's using that visualization function to actually retrieve, locate where the chunks are coming from. We'll create our RAG pipeline for response generation, so it's just taking the prompt, right? Taking the relevant chunks and feeding it as a prompt to our actual model, our Granite 8B model that we also have to replicate. And then this is setting the document prompt template, and then creating our full chain right here. So we're setting the model prompt template, document prompt template, and document separator. And then we're creating a RAG chain, and then we can generate response using that RAG chain. So we're just creating a fairly basic laying chain RAG pipeline, but just using the visual grounding, adding a little visual grounding step as a bonus to the pipeline. So we can actually go ahead and test that full pipeline using the same query as before, right? So how much was spent compared to the amount of food distributed? So using our RAG visual grounding pipeline, we can see, so it's retrieved 5 relevant chunks here. So if we actually go through the relevant retrieved chunks, the first chunk is a text chunk. Let's see, value of food distributed, okay. Okay, so it kind of just retrieved only this little piece of text that was at the top of the table. Not a very great chunk, and also just not going to answer our question. So we're retrieving 5 chunks because this is very common with retrieval. Let's see the next chunk. The next chunk is going to be an AI-generated image description. This image contains, let's see what the image is. Awesome, so that's exactly what we're looking for, right? It's $13 million spent, yields $383 million of food distributed. So we know that the second chunk it retrieved is correct. It's still going to go for 5 because that's what we set our top K to. But we know that the answer is existing in these chunks. So when we look at the actual answer, we can see this image shows that $13 million spent would result in the distribution of $383 million of food. Perfect, right? So essentially, we have our correct answer here. We also can tell that our answer has been extracted from an image, which kind of highlights that multimodal part, right? It's extracting this image, but we are also able to go and verify the image itself. So that's where the visual grounding comes in, right? It's like knowing exactly where that information is coming from and also being able to verify. Like, this is not a super simple image, right? It's not like the most direct relationship in terms of the text that's in the image. So being able to go back and verify that the image is actually being processed correctly is the benefit of that multimodal aspect of the RAG. So I think that is actually it for the last lab. So I'm quite early here. I hope that there are some other questions or discussions that we can have. Are there any other questions about RAG or about Docling as a whole? Go ahead.
So I have no idea. I have no context on what you just went over. Like in terms of like the use case. So like this is what you guys have created is essentially preparing. I was just reading about on your website is preparing all this information from PDFs, etc., for like consumption by who would be using this to analyze what information. I guess I don't really know like the real world application.
Yeah, good question. So to answer that, we can actually look at when Docling was kind of created in open source. So when we were on a project called InstructLab a while back, and part of that project was being able to take essentially Wikipedia articles and extract them into Markdown text. And the reason why you want to extract them into Markdown text has to do with the fact that when you feed text into a large language model, or generally for AI, so we actually wanted to take that text and use it as training data for something else, but that text needs to be in like Markdown format or text format or HTML format, right? So like the text, largely you need text in text format for it to be used in these AI applications. And PDF was a big one, right? We receive a lot of PDF documents that we really wanted to use for training or we really wanted to use in like a RAG situation, but PDFs aren't always easily extractable, right? Like if you've tried to take a PDF, even a parsable one where you can like highlight the text on it, if you try to highlight a couple lines, you'll see it like jumps around, right? Like the actual text within the PDF is not structured in the way that the PDF actually looks. And same with like scanned PDFs, those are even more difficult, right? Like actually extracting text out of a scanned PDF to be used in an AI application is just as difficult, right? So the whole need for Docling was sort of born out of this lack of ability, at least open source projects, to do this sort of text extraction. Now, there are actually a lot of services that do this as well. Like I think Azure has a document AI, Google has something very similar. So there's a lot of these closed source services that essentially provide the exact, am I pressing? It doesn't matter. It's essentially they provide the exact same thing, right, as doing that text extraction. And that's the main thing, is it kind of highlights the need for us there, right? Like taking documents of various formats and using them in AI, like taking real world documents and actually being able to use them in an AI application. That's the goal of Docling. And with it being open source and with it being locally executable, that also adds a layer of security and data privacy. So like any of the closed source solutions that exist, you may need to send your document off to some server somewhere. You may have regulations that prevent that. You may not want to pay for that. Like one of our use cases, or one of the people that we've worked with to help them implement Docling, they actually did a price out of like what 1 million pages would cost them on like Azure, one of the Google services. It's like $30,000 for 1 million pages, which is, it's a lot of money if you have a lot of documents essentially, right? So the idea of docking is if you have compute, why not do it yourself?
Cool. Yeah, that's helpful.
Any other questions about that?
One thing that, this doesn't have a ton of applicability and stuff that I do, but one thing that I was curious about is we did a project where we had piloted a database of scanned historical water rights information. So going back 100+ years of who has a right to water where in California. And these PDFs are of all different types of quality. They look like a 100-year-old like manuscript with a flowy thing. Sometimes it's screenshots of like a 90s IDE and so the data is really wild. And I was just curious, could one of those get plugged into here and could something reasonable come out of it?
Yeah. So handwriting documents and sort of more textually complex documents are something that a lot of people have come to us with. It really heavily depends on the quality of the text. So Docling is primarily focused on the text extraction, and when you run OCR on it, it tries to recognize text like as a first, like the highest level. And so because of that, if there's text that it doesn't recognize, if there's handwriting that looks not like text, what it'll end up doing is extracting it as an image. Now this isn't necessarily a bad thing either, because one use case that we're looking at is people that have filled out forms on paper. So like there is a lot of text on the paper, but there's also handwriting, right? One thing that Docling is able to do is extract the text, but also extract the handwriting as images if it's particularly bad, and then you can process the handwriting images as images using like a handwriting specific model, right? It's like using models that are specifically targeted towards handwriting, and that also saves you a lot of compute because you're not processing the entire document every single time using like a handwriting analysis model. You're only processing the specific chunks of it that are unrecognizable as text in handwriting.
Got it. So if it's reasonably OCRable, then that's a good candidate. But if it's like...
Yeah, exactly. And within the PDF pipeline, Docling has several OCR models that you can choose from in terms of like what OCR you actually use. So if you had an OCR that worked particularly well already, you could use Docling. You could use that OCR within the Docling conversion pipeline.
Sweet.
Yep. Anything else? Okay, great. Well then, in that case, I'm just going to wrap it up with a couple of ways you can check out Docling. Obviously, it's on GitHub. There's also a Docling Discord now if you're interested in using Docling and you have any questions. It's very active in terms of getting your questions answered. And we will also, it's an LFA on data project now, and so there's an LFA on data mailing list that would strictly be for community meeting notifications. We actually just had our first one today, but also just we have people come and present their specific implementation of Docling and highlight those, and then also we answer questions and give the newest updates for Docling releases. Yes?
Okay, so a very new question, but if I wanted to get started with something like Docling or LangChain or any of these tools that leverage generative AI to get structured data out of something messy, how do I know I don't need to be worried about hallucinations somewhere in that process?
So no is difficult, right? Like if you have a long document and you're unwilling to review all of the text to compare it to your document, it's very hard to necessarily say, I know that this was converted correctly. One thing that Docling and the Docling team is working on now is, in the past, there wasn't really a good way to test the quality, like actually measure the quality of an extraction of a document conversion, because there wasn't really like a data set that was like, this is what the ground truth of the extraction is, right? So we're actually working on building out a data set to do that like ground truth comparison so that we can actually directly compare a Docling output versus like an Azure output versus a different OCR model output, whatever, right? But I think when it comes to the specific conversion piece, hallucination is very difficult to say, oh, I know for a fact that it's correct. That being said, for the majority of PDFs that are not scanned PDFs, those are all parsable, so the text you know for a fact is going to be accurate, right? Like the text is going to be extractable and accurate. The structure itself, it may hallucinate on, but it's not usually a problem that would cause like significant issues down the line. Maybe like a small list is out of order or something like that, but nothing major.
Okay, and follow up, it's okay.
Yep.
Have you noticed patterns in like when you think hallucinations are more likely to occur, like based on maybe the structure of the data you're asking for it to interact with in the first place?
So hallucinations are going to be more likely in scan documents, and if they would occur, they would probably occur more commonly using the VLM model, right? So that single shot conversion may result in some hallucinations just because the structure of those documents is a lot more complex, and you're trying to recognize smaller pieces of the document using like a model that's looking at the page as a whole. I'm not really sure about patterns. Like if you look at the actual data set the Docling model is trained on, a lot of the data is going to be scientific articles, which is, so it would probably process scientific articles particularly well. Maybe data structures that are outside of like traditional PDFs, maybe a little bit more difficult because the model is not tuned to those. But one thing that the one interesting piece of data that the Docling model is also trained on, the Gradient Docling model is also trained on, is pictures of documents, like phone pictures of PDF documents. And that was actually using generated synthetic data. So we took PDFs and then created a bunch of synthetic data of those PDFs that looked like they were in like everyday environments, and then used those as training examples. But that's all to say, there's a lot of different types of documents that are being trained on, but they tend to be more of the common structures of PDFs. Maybe if there's a particularly advanced PDF, they may have trouble.
Okay, thank you. Super
Yep.
helpful.
Anything else?
I have like a particular thing in mind, so I'm not sure if this would apply, but has anyone used the Docling to parse existing documentation that was probably generated with Sphinx, and they might have, I don't know, some screenshots of stuff that could have actions to do, and then being able to pass that to an agent to test it, like in a browser or something like it?
So parsing a document that has screenshots within the document?
Right, so I'm thinking of, you have a documentation page that is live, like, let's say the NumPy documentation. It's
Okay.
created with Sphinx and it has this bunch of markdowns and stuff. But in certain scenarios, it might have some screenshots of, look at this, I don't know, workflow, or try this, or let's say that you have some, I don't know, AWS clicking things to how to deploy an EC2, right? Would it be able to be used to kind of parse the information in that screenshot and generate actions for an agent and go test it?
So there actually is a Docling MCP tool that's available, but that is just for document conversion. I would say if you have images or screenshots within the document that you would want to reprocess, I mean, it would be probably just as simple as processing the page using Docling, right? So this is like a markdown page that includes embedded images, processing that page using Docling, and then feeding the images within that page into Docling again. I mean, like, theoretically, you'd just be able to process all of the screenshots as their own pages, and then from there you could generate, or you could use like a visual language model to process those images separately.
I'm thinking more of an application, so something that I was just trying to get instructions out of a screenshot. Do you know that sometimes you have a UI interface into some tool, and you get screenshots of clicking here and doing this, and you show screenshots? Kind of generating.
Right. I mean, I would say to try just like a basic VLM and see how it works. Like if you look at the conversion if you look at the text-based, the AI-generated image descriptions, especially when you're using like a fairly large image model, it's a pretty detailed image description. You know, like if you have like a UI that's like or like a flow chart or something that's part of it, it does a pretty good job of generating the accurate information out of that flow chart. In terms of like converting that into instructions for an agent, that probably.
Yeah, that's probably the next step.
Yeah, exactly. That might be
But
something
you're trying to
process.
extract the text from.
Right, extracting the text is, yeah, that's no problem for Docling to do. It's more just, I don't know how you would actually, but yeah, that's.
Well, all documentation, I mean, at least like a big chunk of the PyData libraries are generated with Sphinx, which end up on HTML, so
Okay.
that could work.
Okay, yeah. I mean, HTML is a very easily
Yeah, and it's
parsable
all
format.
buttons.
Yeah, so it's just a matter of taking the images and processing them
Yeah.
independently. Yeah. Awesome. Okay, if that is it, then I also have, they're in the back too, there's a bunch of Docling stickers. People really like the Docling logo, but most importantly about the Docling stickers is they have QR codes on them that take you to the Docling repo. So if you want a Docling sticker, there's a bunch in the back. If they run out, you can come and ask me for more. I also have a bunch. But thank you very much. I think that is it for me.